Afternoon, girls. So today we're going to be doing transformation of trigonometric functions, which just means learning to draw trigonometric graphs. It's not too different to what we just finished off. So we're still doing vertical dilation, horizontal dilation, and translations and so on, but they just have slightly different words when it comes to trigonometric graphs. All right. So let me just point out the terms. The vertical dilation of trigonometric graphs is the amplitude, okay? And the amplitude is basically the number in front of a trigonometric functions, and that's basically the y-intercepts of a trigonometric graph, okay? Instead of me going through all these descriptions, let's talk one at a time. So for vertical dilation, let's have a look at that example to illustrate that. Now, if I was to draw this, what I would want to start off by drawing is drawing just 2 sine x first, okay? So label the 2 on the y-axis. So that means he has to go to 3 minus 2, which we've learned last term. And sine x graph just basically looks like this. So just draw one sine wave, and one sine wave ends at 2 pi, okay? This question means they want you to draw the graph from 0 to 2 pi, and that's basically the graph of 2 sine x. From here, now if I want to draw minus 2 sine x, you're just flipping this graph upside down. So it's going to look like this. Okay, so this would be your graph of minus 2 sine x. Okay, so this is an example of vertical dilation. Whatever the number is in front of the trigonometric function, that's what the values are on the y-axis. So the peak or the amplitude. Okay. Now, for horizontal dilation, I will illustrate that using this example here. So remember, horizontal dilation is, once again, it makes the graph thinner or wider, but it really depends on the x values. So horizontal dilation in trigonometric graph is a period, and that's the point on the x-axis where one wave ends. So, and it's got different periods for different trigonometric functions. So in our question, it's sine. So let's use that formula there. So what we want to do first of all is find the period. So you do 2 pi divided by the number in front of x. In this case is a half. So 2 divided by half, that's 4. So that means one sine graph ends at 4 pi. So let's draw one sine graph or wave. Okay. Oh, and once again, if there's no number in front of that, it means 1. So that means the amplitude is going to be 1 and minus 1. And one sine wave ends at 4 pi. But you need to read the question carefully. They want you to graph it from 0 to 2 pi. So that means 2 pi is going to be halfway through 4 pi, which means 2 pi is there. So rub this bit off, and that's all you want to show in your answer. Just that. Okay, so this is your example of horizontal dilation. So as you can see from your normal sine graph, it's actually gone wider, right? Stretched out, because the x value, or in this case the pi's, have increased. So that's basically horizontal dilation. Just keep in mind for tan, one wave ends at pi over a, and one wave for tan, I'll just quickly draw it, but I've taught you this before. Okay, that's your one wave. Yeah. All right, so that's horizontal dilation. Now this example would be for vertical translation, and for vertical translation in trigonometric graph is the center of the graph, okay? That's how it's described. So if I want to draw a cos graph that's shifted down by 3 units, what you want to draw is just draw cos graph first. So let's do that. So let's draw cos graph. So once again from 0 to 2 pi. And one cos graph looks like this. Let's say that's my cos graph, and that's my amplitude there. And here it ends at 2 pi. And halfway through that, let's just label another one, pi there. All right, so if it gets shifted down by 3 units, so let's take that point. That's going to go down by 3 units. So that's 0. So 1, 2, 3. So that point is now going to be at minus 2. And that very bottom peak there, instead of going through minus 1, if we go 3 units down, it's going to go through minus 4. So we got a dot there. So that comes down here. And obviously, once again, that's at 1. So that's going to come down to minus 2. So let's draw that pattern. So that would be your graph of cos x minus 3. All right? Now, the reason why minus 3 is the center of the graph. Yeah, so the center of the graph is basically the number that you're shifting up or down by. So minus 3 is your center of the graph, because see how minus 3 is there? If you draw a dotted line, can you see that's like the center of the graph? Cuts the graph in half. So that's how they describe vertical translation. Whatever you're vertically translating by represents the center of the graph, right? Which cuts in half. So yeah. Now let's go through an example of horizontal translation. That's the kind of the annoying part, which you gotta do a bit of work. Alright, so here's an example of horizontal translation. So what that means, inside here obviously means x is equal to positive pi over 2. So that means you're going to shift the tan graph by pi over 2 units to the right. Before you do that, what you want to do is draw just tan x graph. So let's just draw tan x, and it looks like this. And remember, it's from 0 to 2 pi, so I'm going to draw up until here. So that's 2 pi there. Now, when it comes to horizontal translation, you want to label as many x-intercepts as possible. All right, so halfway through 2 pi is pi. Now, this one is pi over 2. This one is 3 pi over 2. Okay, and that's obviously 0. I'll just label that. So, now here's my key tip to get things accurate. You want to translate the asymptotes first. So, see these asymptotes? So let me label all these points here. So you've got pi over 2, and you've got 3 pi over 2. So I like to draw like another separate axis. So if I'm adding pi over 2, that means pi over 2 plus another pi over 2 is what's going to get me to pi, right? So that's where my new asymptote is now. So instead of the dots being there, it's now at pi. Similarly, for 3 pi over 2, if I add pi over 2, I get to 2 pi. So this asymptote is now going to be at 2 pi. So 2 pi. Okay, so you do your asymptotes first. It makes your life a bit easier. Now let's start doing the graph. So let's start with the center. So that bit is obviously now going to be in here. That bit is now obviously going to be here, where that point is 2 pi plus pi over 2, which is 5 pi over 2. And then obviously got now this bit, which is now here. And then you want to continue this part as well, which, going by the pattern, you just continue that bit. Now, once you've done that, make sure you look at the question. They want it from 0 to 2 pi. So that means you need to rub off that bit, because we want it up until 2 pi only. So keep that in mind. And that would be your final answer. All right, so that's my tip when it comes to horizontal translation. Do another separate axis and then translate the asymptotes first and then the points. Now, final question to wrap it up. Let's do tan graph again, but if it's got minus x inside, do you guys remember what that means? If it's got minus x inside, it means reflect the graph. Yeah, all right. And remember, the question now wants from minus pi to pi. Usually when that's not given, they usually always want you to graph it from 0 to 2 pi, but it's always important to keep in mind what they want you to draw in, the domain they want you to draw it in. So let's start by drawing here. Let's just draw tan x to start off with. So now I'm just going to do it let's do it on the positive side first. So we got 0, just copying that, but just up until pi. So that's pi over 2. That's pi there. Okay, so just up until pi on this side. Now, if I continue this pattern, here obviously then you've got pi over 2, then it's going to be minus pi over 2 here. And then with that side, yeah, it's going to be like this then, yeah? and that's negative pi. Yeah, does that make sense? All right, once we've got that, now we need to reflect in the y-axis, so we're basically just like flipping it this way. So the asymptotes obviously stay the same. Now, this is going to look this way. Now, instead of going that way, it's going to look this. Instead of going up, it's going to, how do you do that? Instead of going like that way, yeah, it's going to look this way then. Yeah, so it's just basically like you drawing that side here and you're drawing that side here. That's one way to look at it. All right, girls, that's basically enough. That should be enough to get you through the questions. Do questions 1 to 9 and let me know how you go. All right, thanks.